We've talked about conduction, convection, and radiation. Radiation is the movement of heat through a space without heating that space until it strikes an object. It's also described as the movement of heat through waves. And I'm not talking about parades, I'm talking about through wavelengths. So if we look at radiation as a type of energy form, just like radio waves and any other kind of waves, the waves go up and down and up and down, and it travels in waves. We can't see these waves, but it's a very important type of heating. The biggest radiation that we have for heating the earth comes from the sun. It travels in radiant waves. It travels through that space without heating the space until it strikes an object, such as the earth, for example. And a big part of radiant heat for us is the glass. It comes in through our house through the glass. So radiant heat, they always talk about taking temperature, and temperature is always taken in the shade. They'll say it's going to be 105 degrees in the shade, because any temperature is always taken in the shade because the radiant factor of that heat is astronomical, and there's no effective way of measuring it for the most part. So temperature is always measured in the shade because the radiant heat factor is different. If you've done any work outside, doing landscaping, farm work, working on a roof, you can really tell the difference of that radiant heat. It can really have an effect on you. Also, if you think about driving, also think about truck drivers or anybody driving a vehicle. They're more likely to have sunburns on this side in the US because the sun travels through the glass and it strikes that object, and that's where you're having heat transfer, as well as other types of waves that have an effect on that as well. But that's radiant energy. It travels through a space without heating that space until it strikes an object. So if we think about houses, most of our houses have something like this. No, it's not really a picture that has the frame. I'm talking about a window. So let's imagine that this is a window. The sunlight comes through that window like it's not even there. And then once it actually strikes an object, say the floor or furniture, then we start having heat transfer. The sun strikes that object, that radiant energy starts heating that object up. That energy then spreads to other parts by conduction because it's conducting it. It spreads through the air by conduction. Then the air has convection and starts rising up because the air gets less dense and lighter, and we start having all kinds of energy movements. This is why you'll see people put drapes up. The idea behind drapes is the heat energy travels through the glass and hits the drapes right here. And the heat energy is contained in one spot before it transfers all the way and infiltrates to the house. This is also a big part of having different types of window tint. Different types of window tint can absorb or stop or slow down a lot of that radiant energy. So it's very important. Now you'll see glasses being sold with low E and things like that to help slow down that radiant heat that's coming through that. Now a lot of houses are being built different now. We have different color roofs and different types of roofing material. I heard just recently they come out with a new type of white paint that's even brighter, but more importantly, more reflective. The idea is the sunlight comes down and hits that, and it reflects some of that heat energy back away from the earth. A good part of the heat energy from the sun is reflected back through the earth, back out into the atmosphere. This is where we talk about climate change and potentials, and there's a whole lot of controversy that goes in with that. But as the sunlight strikes the earth, the wavelength that's reflected back is a little bit different, and some of that can get caught up in their atmosphere. Now I'm trying to stay away from all political stuff so I don't upset people on both sides because I have my own opinions and my own views, but the fact is that a lot of that radiant energy does reflect back out into space. And it is really interesting to think about that. We have different types of roofing. For example, in the northern part of the US, you'll see a lot of black roofs or darker colored roofs. They have most of their time in the winter. So they want to absorb the heat energy from the sun. They want to absorb that radiant energy, and it keeps the snow melted, helps keep the house warmer. In the south, you really want to have a reflective roof, something of silver, a type of white, something that reflects that energy back off. So that way the heat energy, the radiant energy hits, and some of that's reflected back away. It makes a huge difference. The problem is people from the north will move to the south and think, wow, I really love that black roof. I want to bring my black roof with me. Well, the problem is that absorbs all that heat energy. So all of this radiant energy is very, very important. Let's also think a little bit farther. Our bodies also radiate some heat out, as well as all these objects will radiate heat out. Just about everything that has a heat source not only transfers heat by conduction, but also radiant energy as well. But we can use that for our advantage. Let's think about some restaurants. Especially this last year, we have a lot of restaurants moving to the outside, or I just like to sit outside anyways. Before all this happened, I like to just sit outside, but sometimes it's too less heated out there for me to enjoy it. So what we can do is heat that space. Now the problem is you're sitting outside, and you have to have massive amount of heaters trying to heat the space. And then that natural convection, the heat just keeps leaving as fast as you can make it. But if we use radiant energy, We can use these radiant tubes, whether it's fire or electric, and it causes these heat waves. It travels through the air without heating the air until it strikes an object, such as me. So this way I can sit outside and be warm because of the radiant energy coming out. It's a very nice effect. So now we can sit down, we can have the radiant heaters, we can feel warm and still be outside, which is a huge benefit. That's also, campfires has a big radiant heat factor because you can feel the heat radiating off of that fire. It helps. It's a nice warming effect. We can also use that for other parts too. Think of food service. I want to cook all this food, I want to keep it warm, but I want to have people see it. But if I heat this space, I'm losing all this heat. Radiant energy. We can have heat shining directly on the food, and that radiant energy is going into the food instead of heating all that air around it. It saves a lot of energy. Plus, let's think of this another way. Mechanics. You have a huge mechanic shop, the doors are open, trucks are coming in, trucks are coming out, etc. Well, you can't afford to heat that whole entire space. But if you use radiant heat, or even in workstations where you have a radiant heat coming down, and that's heating the people and the objects instead of it heating all of the air. It's a very effective way of heating. So radiant heat's important. Now, when we deal with evaporative coolers and heaters, there's a radiant heat effect. When we're taking our temperatures, we want to take our temperature far enough away from an object that we're getting true air temperature and we're not picking up a radiant temperature, because that will throw our numbers off. If you've ever taken a thermometer and you put it actually into the sun, it can ruin it very quickly because all that radiant heat will damage the thermometer in no time. So radiant energy is a very important thing to think about with heat size. We also deal with windows. We want to make sure the windows are the right size. But before you jump out and start replacing all your windows, there's many other things you can do, such as different types of blinds, different types of curtains. And what's more important than the window is how well sealed it is. Moving air through insulation makes insulation a filter and not insulation at all. So having a house that's sealed is much more important than, say, better built windows. And there's lots and lots of options that we can do, and there's lots more to learn about this. But radiant energy, you can look up tons of stuff, there's tons of information about it. Let's just do a quick little example for radiant energy. So here I have this little device to help demonstrate some radiant energy. I'll have my light, and I'm going to shine my light on it, and you can actually see it start to spin. That's a transfer of heat through radiant energy. So it's really pretty cool. It just gives you an idea. This is pretty much useless for anything other than just giving you a concept of heat traveling through a space, but it is a method of heat transfer. So when you're sitting on the couch, you heat the couch by conduction. Your body is warmer than the couch, it transfers heat to the couch. Your body is warmer than the air, it transfers heat to the air. The air, though, becomes less dense and starts to rise because the cooler, denser air moves in. So now you're heating the air around you also by convection. And then naturally our body source is warm and we're radiating some of the heat out away from our body naturally anyways. So our body transfers heat really with all three ways, conduction being the most primary way. And a fire does that same thing as well, conduction, convection, and radiation. You can feel the radiant heat from the fire, but also that energy is heating the air, and that's causing the air to become lighter, drafting up, which is why the smoke travels up. The cooler air is actually pushing that up, and it'll heat by conduction as well, because anything that touches that fire, it's conducting heat into that fire, that object, and then that's transferring heat to other things. So put a rock right up next to it, you can feel that rock, or put the rock in the fire, conduction, you've touched that rock, you're going to burn yourself, etc., etc., etc. But think about all the different ways of heat transfer, conduction, convection, radiation, and have a song that goes with it. I'll link that YouTube channel to the end of this video. It's really cool. Conduction, convection, radiation. Hopefully help you remember those three.